once a month we have a tech night to do some knowledge sharing and some networking. And today we have the tech night. Prashant, a familiar face also at the tech night. Can I have your second?
Yeah, that's right.
Sweet. Okay. About high-performance websites. So I hope you all enjoy the evening. If you have any questions, we have some drinks and some something to eat after the tech night. So please let us know if you have any questions and enjoy.
So, first of all, yeah, thank you very much, Developers.nl, for giving me the stage again tonight. And yeah, I see some familiar faces as well, so great to have you guys back. Today we'll be taking a journey to a performance website. Before I start the chatter, a little bit about myself for people who don't know me. I'm Prashant. You can find me on Twitter under the same full name. It's difficult to remember, but let's share later. Originally I come from Nepal. 10 years ago I came to Netherlands for studies, after which I started working as a web developer, and recently I landed at a company, oh there's my Twitter handle. Recently I landed at a company called Nondutch, for whom I've been working for a year. Talking about Nondutch, this talk is about the Google Day we had in Nondutch. Google Day is sort of like a hackathon day where we get to tinker with whatever we want. And in our last Google Day, me together with a bunch of other non-Dutchers, we decided to sit down and make non-Dutch fast. Why? Because like everybody else, we wanted a fast website, but also because a bunch of us have been giving talks about performance, progressive web apps, and using dev tools to hunt down performance issues. So it made sense for us to set an example by having a blazing fast website that's built on cutting-edge technologies, right? So that's what we did. And today is about sharing with you guys that journey. I want this talk to be not really a talk, but it can be completely interactive. So if you have any question or suggestion, just raise your hand and we'll just have a chat, basically. Right? So the first thing the question that popped up when we started talking about performance was, what is fast enough? So by the end of the day, when do we declare that non-Dutch is like fast, right? And then what is our performance budget? So there are a lot of patterns that have been invented to answer these exact questions. Google's rel pattern being one of the most used and famous ones, but we took a slightly different approach. What we did was we took 3 of the best performance benchmarking tools that are out there, and we decided to go for a minimum on all 3 of those. And those tools are Google PSI, Page Speed Insights. For people who don't know about this, it's just a little tool. So if you go to, there we go. Google Page Speed Insights. It's just a tiny little web tool where you can drop in a URL, and then Google will audit your website against a set of industry best practices and rank your website based on how you did, right? And it gives a suggestion what you can improve, and you get a number out of 1 to 100 and see how you did. So basically, we wanted to get 90 plus on Google PSI. That was one. The next thing was getting less than 1,000 milliseconds of speed index on web page test. What is web page test? If you do anything performance, web page test is really, really indispensable tool, because it not only allows you to analyze the network activity, the CPU activity that happens when your application loads, but it allows you to emulate users on different locations in the world and on different network conditions. So you can emulate how the application loads and works for a user in India on a bad 3G connection, all for free. You do have to stand behind a queue, but it's usually just a few minutes, and it works great. And it gives you nice insights into how your application loads, a lot of data, a lot of metrics. And one of the metrics is speed index. So what is the speed index, right? So previously, back in the days, we used to, gauge the performance of our application based on the load time, when the window object gets the load event, right? But that's not really a good indicator of your performance, because load time gets fired way after when the user sees the meaningful content on the screen. So for example, if there are lots of images below the fold, user already sees what's happening on your application, but the load time fires after all the images are loaded, after all the fonts are loaded and all that. That's not really how the user perceives your application. Speed index is this algorithm invented by brilliant guys at Google, which actually calculates how, on what time the meaningful content of your application, the amount that is above the fold and is useful for the user appeared on the screen. So less the better, right? So we wanted to go for less than 1 second. Speed index on web page test. And the last one was 90 plus on progressive web app Lighthouse. Lighthouse is another tool developed by guys at Google. It's basically sort of like Google PageSpeed Insights, but comes in different flavors, and it basically runs your website against cutting edge best practices. Things like how's your time to first paint, time to first meaningful paint, is your website offline ready, how do you do on progressive web app standards, how's your accessibility, and all that good stuff. And good thing about Lighthouse is it comes in different flavors. You've got Chrome extension, which looks like this. So you click on here and you run Lighthouse against whatever website you want. It also comes as a CLI tool, so you can integrate it into your CI pipeline. So you can continuously check how your application is performing. And it's starting recently, it's on Chrome Canary, but it's baked into the DevTools. So the new audits tab is actually running Lighthouse 2.0. And if you perform an audit and it tells you like, what do you want to do? Performance, progressive web app, best practice, accessibility, runs it against the website, gives you a lot of scores, a lot of suggestions, and all that cool stuff. I'm not going to do that. So that's Lighthouse. And we wanted to achieve 90 plus on progressive web app Lighthouse as well. So after all this goal set, we started profiling and analyzing. We started trying to find out the low-hanging fruits for improving the performance. And there were lots of suggestions we collected already from PageSpeed Insights, Lighthouse, and webpage tests themselves. The result of all this was a Trello board full of issues that we were going to pick one by one in a hope that we would increase the performance of our website, right? And so as you can see, there are a lot of to-dos here as well. So we didn't finish everything, but I do want to share the things that we want to include in the website in the future as well, just because to share the knowledge. So, first thing, when it comes to performance, you gotta have efficient content. What does that mean? It means that you gotta send down as less data as you need down the wire for your users. Why did we want to do that? We have Google Analytics running on the website, and we noticed that most of our visitors are from countries like Eastern Europe, India, places where data is not as cheap or accessible as in Holland, right? So we wanted our content to be as lean as we can make it, so that it's as cheap as it can get for users. There's a website called whatdoesmysitecost.com, and basically you drop in a URL sort of like PageSpeed Insights, and it will tell you how much your website costs if it's loaded in many different countries in prepaid plans and postpaid or whatever. So I think it's using a web page test in the background, so it's going to take a little while. Maybe we can get back to you later. But we wanted our website to be as cheap as possible as well, because we want to cater to users, to all the users, from one end to the other end of the spectrum. So how do you do that? Usually, when it comes to efficient content, it's a lot about compressing and caching, right? You gotta compress your text-based assets with things like gzip. You gotta have optimized images. You gotta cache things so that it never hits the network and stuff like that. And usually, these things are easy to achieve by configuring some things on the server. And for us, these were like low-hanging fruits that we quickly changed in our server configurations, and we got a lot of speed improvements, and our rankings got high immediately on all these tools that I told you of. But I want to take this moment to share this project that we found with you guys, which is HTML5 boilerplate server configs. HTML5 boilerplate is a project that back in the day when HTML5 was young and popping, they created this boilerplate project on the GitHub, which you can just use to set up your HTML5 project. But they also have this sub-project called HTML5 server configs, which allows you to check out the configuration on most popular web servers that are out there. For example, we got Nginx, so we went in Nginx, and it tells you about, let's see, Apache is better. So it basically, you get the server configuration for things like performance, security, and all that. And it's mostly a matter of just copying and pasting these things into your server configuration file, reload the server, and things will work immediately. But these are like community-driven server configuration, and it's really, really well commented, so you can read why you are configuring the server that way. This is really helpful. So I wanted to share that with you guys. So also things like usual textbook stuff, like gzip text-based access. We all know that, we've all heard it for a long time. But how can we take it a step further? We got Broadly, which is a new compression algorithm shared by, I think invented by Google in early 2015 or something. And Broadly is also a compression algorithm that's supposed to have denser compression ratio compared to gzip or deflate. But you cannot just drop in Broadly on every resource you have, because it does higher compression in expense of higher computing power. So if you actually drop in Broadly on all the assets that you have, you may actually end up having higher time to first byte, which is not good. But there is a certain, you can play with the level of compression as well. So there's a certain rule of thumb. If you have like compression level set to 4, then you usually get higher compression in lesser computing power. But we couldn't manage to install Broadly in our web servers on that Google day because it's not supported by any of the web servers right now. You need to compile, install this module, Broadly module, and compile the web server yourself, which is not a trivial thing to do. But it's something that's definitely worth keeping our eye on because it's supported by all the major browsers right now. So for content efficiency, Broadly is great.
How far back is Broadly implemented in all of the browsers?
How far back?
Yes.
How far back browsers-wise?
Yes.
IE 11 and up, if I remember correctly. Yeah. Image optimization. So yeah, of course, you gotta have optimized images, right? There are lots of tools that you can include in your pipeline that will optimize the images for you. But one thing we did differently was to use progressive JPEGs. So what are progressive JPEGs? There are two variants of JPEGs floating around on the internet, which is baseline JPEG and progressive JPEG. Baseline JPEGs are most of the JPEGs that you see on the internet are baseline JPEGs. And progressive JPEGs are another version of JPEGs where in baseline JPEG, the browser receives the data and renders the images line by line. From top left, it goes down, and then that's how we see the JPEGs being rendered, right? But progressive JPEGs get rendered in passes. First, the low resolution variation comes in, and then on several passes, the browser keeps improving the version. But for the mobile devices, the low resolution version comes in really fast. And on a small device, it appears to load a lot faster. So for users' perceived performance, progressive JPEG is really, really wonderful. And I've got a demo for you guys for this one, which is over here. So what I'm gonna do, I'm gonna throttle the network to 3G, so 3G, and run this example. So I got 3 different versions of images here, and so as you can see, progressive JPEG loads like really fast, right? On a smaller screen, you won't even notice the resolution difference, but it looks like it's already completed, but it's actually still loading, and it's in lower resolution. And then we got another version over there on the right, which is loading pretty fast as well. And this is the baseline image. The most common form of JPEGs on the internet right now is actually the slowest version. So let's reveal some data about it. So baseline JPEGs, the regular form, is 876 kilobyte. And then we got progressive JPEG. It's a tad bit smaller than the baseline counterpart. And then it just finally loaded. And then we got WebP, which is a new image format from Google as well. And it's a lot less in size, right? It's really, really highly compressed. It's just 296 kilobyte with the same quality ratio. So I'm going to talk more about WebP as well. So we made sure that all of our JPEGs are progressive JPEGs. So so our meaningful content, the time to first paint, becomes really fast because the initial render happens with the lower resolution. That means the user gets to see something happening on the screen really fast. So
is there something similar for PNG?
Progressive PNGs? Yeah. No, there isn't. No. So we got the WebP. Like I said, WebP is a new image format from Google, which is supposed to, on average, supposed to be 30% lighter than the JPEG counterpart. Not the best browser support. It's only supported on Blink-based browsers, so Opera and Chrome. But it's easy to implement. It's easy to progressively enhance your application to use progressive WebP using picture elements, right? So we got picture elements nowadays where you can define sources. So for like high DPI screens, we got 2x.webp, and we tell the browser like, if you support WebP, then grab the WebP for me, and the browser is going to ignore the rest if it understands the picture element and WebP. So for the browsers like Safari, it understands picture element, but it doesn't know WebP, so it's just going to ignore WebP, and it's going to download JPEG. And for the browser that doesn't understand picture element at all, it's just going to go back to the fallback JPEG. So that's really easy to implement even now and get the benefit of those 30% savings. The next thing we did, lazy load images. A lot of images are below the fold, which do not need to load on the initial for the initial rendering of the page. Yeah, there are lots of plugins around lazy load images. We've heard it for a long time, right? What I want to share with you guys is this new web API, also experimental. That's really, really cool, and it's intersection observer. We are actually using this in production right now because it's easy to feature detect. You just check if intersection observer is in window and do your thing. So what is intersection observer? It's a native browser API, and basically it's an observer that you can pass a callback to, and the browser is going to tell you whenever the element you're observing appears inside the viewport. This is exactly what we want for lazy loading images, right? So if the images appear in the viewport, or the element that's image tag appears inside the viewport, then load the actual image. Up until then, load some dummy image or something like that. Let me show you a demo of how that looks. So basically, I got this image over here, and as you scroll down, you see the images coming to the network. Now the best thing, why use intersection observer? First of all, you don't have to use all those jank-inducing scroll listeners or jank-inducing get bounding client rec to determine whether or not your images are in the viewport. It's just something that browser natively tells you, right? That's a lot cheaper, and browser can handle it internally for even better performance. But the next thing, the better thing is the code. The code is really, really simple. For lazy loading, you usually grabbing like hundreds of lines of code from an external library or something. But with intersection observer, this is the code. So let me go through the code real quick. So first of all, we create an observer instance, right? Intersection observer, and we pass a callback to it. What do we want to happen when the browser detects some intersection? So down here, I get all the images that are lazy images, converted into an array using the spread operator, and for each of the image, I use the observer to observe it, right? So whenever the image appears within the viewport, the browser is going to call my callback, and within the callback, all I do is apply the actual source from its data attribute. So I have data source and source set to empty, so when the image appears within the viewport, it's changed and the image then gets loaded. Now that's the code is really simple to implement, and you get the performance benefit from the browser. So that's why we implemented intersection observer with an easy feature detection, fallback to some plugin, some JavaScript plugin for image loading. And if the browser supports it, just use intersection observer. So the other thing we use is request idle callback. Now this is a little bit conflicting with what I said before, which is we want our website to be cheap. Why is it conflicting? Because we are using request idle callback to prevent scroll jank. What's happening is like we are lazy loading all the images, but when the user scrolls, then the image comes in, browser has to paint a lot, scroll is not the place you want to do a lot, you want the browsers to do a lot of work because it leads to jittery scroll, right? The scroll doesn't feel natural and smooth. So how do we prevent that? By using this new API, request idle callback, easy to feature detect, supported in these three browsers. There's Firefox nightly, so it's not in stable Firefox, Opera, and Chrome. So what does it do? It basically allows you to pass in a callback that gets invoked by the browser when the main thread of the browser is doing absolutely nothing. So what we do is like we load only the images that's in the fold. We show the meaningful stuff as soon as possible. And then there are lots of images down there which we lazy load. But if the user is not doing anything, if the user is reading something, and the main thread of the browser is idle, we start loading those images, basically making requests for the images. That's really idle for that. The reason it's conflicting is because like the user may never end up requiring those images because they're below the fold. And I talked about like we want our website to be as lean as possible, but then we are getting data from the user. So it's like a bit contradictory, but like to prevent the scroll jank, it's a great mechanism for us to use. And you can use it for many other purposes besides just lazy loading images. Whatever you need to do on the background, heavy calculation or something, if the main thread of the browser is not doing anything, just fire a request idle callback and you get to do that. So the next thing we optimized was the web fonts. Web fonts, mostly like what do we have, TTF, WOF, and all those, right? But we also got WOF2. WOF2 is a newer format which is approximately 30% less chunkier than the WOF counterpart. So there's actually, and it's very easy to implement even though not all the browsers support it. Basically in your font face declaration, just first, the first one to go is WOF2, then WOF, then TDF, then all that. If the browser doesn't understand WOF2, it's just gonna ignore it and go to WOF. So it's really easy to implement. All the font kit generators that you have on the internet, they support WOF2 as well. So it's great. The next thing is we use font loader to get around lazy font loading. So what is lazy font loading? To understand that, we need to understand a little bit about how browsers does stuff. So basically, you define your font stuff in your CSS, right, at font face. So when the browser gets the HTML, it starts parsing the HTML and it starts building the DOM. It sees that, hey, there's a CSS file. It's going to make a request for the CSS file. It gets the CSS file and it starts building the CSOM. And then it starts parsing the CSS. It sees there is a font face. And then it sees that there is a font URL, but it doesn't make a request to the URL. Only when it actually builds a render tree, which is a mixture of DOM and CSOM, and it knows for sure that there is actually text in the page that's going to use the font. Only then is the font requested. Why does browser do that? This is lazy loading behavior by default on all the browsers, so that the browser doesn't end up downloading a lot of fonts are pretty chunky. They don't want to download all this font if they're never used. So they sort of do that for us, but not all the time it works great for us. How do you get around lazy loading? You can use a font loader. The font loader, you have many JavaScript libraries, but there's also a new font face API on natively supported in browser. So basically you use JavaScript to request those fonts that you know for sure is going to be used. And until then, you display a fallback font. So the font appears immediately on the browser. And when the font actually gets downloaded and you get a callback, then you actually apply the proper web font. I'll show you the demo first. So we got web font loading over here. So on the right side is eager font loading using a JavaScript font loader. And on the left side is how the browser does it by default. There's a very slow font and there's a very slow CSS here. So let's reload it. What's happening? Here, the font, we display the text in a fallback font. So the browser has the fallback font. It's usually website. The browser has the text, so it displays immediately. While on the right, the browser waits until the CSS is downloaded. It figures out there is a font to be used, and then fires out the request. And up until there, the browser doesn't show any text. That's the default behavior. And actually, if you check here, the browser first displays this in the fallback font as well, and later when the font arrives, the actual font is applied, right? What the browser does for this one is it actually waits for 3 seconds to wait for the actual font. If the font doesn't arrive until 3 seconds, it will show the fallback font, and after the font arrives, it shows the actual font. So that's the browser behavior. So lazy loading of the font is great to save data, but it's not always useful for user experience. So we implemented this strategy: render text as soon as possible using system font, and render actual font when available. How does the code look like? It's pretty simple actually. So you have a body, we have a default web safe font, so font family of Arial and sans serif. So browser renders all the text that it has immediately with Arial font, and when the body has the class of has fonts loaded, it's going to actually use your fancy font, right? So then we use on JavaScript, there's a font loader. You have many different variants of font loader you can find on the internet. You load your fancy font, and when the font is loaded, it actually adds the class, and then your fancy font gets displayed on the browser. So that's a strategy that we use. But you can also use system UI fonts. This is the strategy that I see many websites using lately, like Medium, GitHub, and all that. What they do is they have this weird looking font family declaration. And it's basically all the system fonts. Like Apple system covers Safari on Mac, Blink Mac system font, Chrome on Mac, Seagull UI Windows, Roboto, Android, and all that. So basically all the system fonts that you can see. And why do that? To prevent the network request completely. So if you use this one, you don't have to rely on any network request for your font to be displayed. The only disadvantage here I can think of is it may not match your design, right? The users will actually see the fonts in how they would see in the operating system. It may not match your design, or maybe the font is a little bit too big, so your buttons shift or something like that. We usually don't want that. But a lot of websites are using this strategy, so I wanted to share it with you guys today. The other thing that's really, really recent is link rel preload. This is a new attribute that you can drop on a link, and I'm telling you, like, hey, request the WOF2 as a font, make sure it's the type WOF2. What does link rel preload do? basically, like I said, the lazy loading of the font. The browser waits until it sees in the CSS there's a font and it knows for sure that there is a text using that font before showing the font. But if you as a developer, you know whether or not your font is going to be used already, right? So what this does is like forces the browser, it's basically telling the browser, like, hey, I know that I'm going to be using font, so download it as soon as possible. So when the browser parses the HTML and sees this, it's going to make the request immediately. You can also use it for other things, like, for example, we're using it for the big background image that we have. It's above the fold, it needs to be there as soon as possible because that forms the biggest chunk of the page, so we request the page immediately using link rel preload as well. So let me show you maybe over here on Chrome. So I'm capturing this performance. So down here, normally images are really low priority. Browsers give priority to CSS, JavaScript before downloading the images because images are, it's fancy stuff, but it's not required for your page's layout and behavior. So they download it with low priority. But our hero image that's on the background is really, really important for the website. So what we do, we load all these images. We load the background image using preload as well. And we load our font using preload as well. So the request shifts a little bit to the left. So it would otherwise be requested somewhere down here after our JavaScript is downloaded and stuff. But now it's shifted to the left immediately with CSS. So first we get the HTML over here. Then we start parsing the HTML. It sees the link rel preload and starts downloading those resources immediately. So the things that you know is going to be useful for the content of your application. Just drop a link rel preload on it, and the browser is going to download those immediately. The next stuff, of course, cache your static content. So yeah, server configuration, drop the cache headers like cache control, max age, 1 year for images, 1 month for JavaScript, CSS, and all that stuff. But there's one new thing that you can apply nowadays, which is cache control immutable. You can mix it up with other cache control headers like max age, just with a comma, max age, 1 year, comma, immutable. Well, what does this do? It prevents revalidations. What does that mean? So when you put, let's say you put a JavaScript, you send out a JavaScript with a cache control max age header of 1 month. That means the browser is going to cache it for a month, right? Unless you change the URL, then it's going to download again. But it's going to cache it for a month. But does it always do that? No. When the user actually clicks the refresh button, which imagine for like Facebook, we're always clicking those refresh buttons, like hundreds of thousands or millions of users at the same time clicking the refresh button. All those caches are actually, the browsers are like, hey, the user clicked the refresh button, so I'm going to actually ask the server just to make sure if things have changed or not. So the request is going to go to the server is going to say like, hey, it's all good, it's still the same. You're going to send back 3 or 4 back, and the browser's then going to use those stuff from the cache. So if you use cache control immutable, it's like telling the browser like, hey, just always use the cache. You don't have to ask us until we tell you. So even if the user clicks the refresh button, it's not going to make this extra round trip to the server to use the stuff from the cache. So imagine millions of users at the same time not having to get those data from your server. That's like petabytes of data saved, right? And we applied the same thing. It's really easy to implement. We dropped in the cache control immutable on our Nginx server for all these JavaScript and images and CSS, and no longer are the requests being sent to the server just to check if things have changed. And we also removed our junk CSS and JavaScript. Those are the CSS and JavaScript that, yeah.
How do you tell the browser it does have to download new image?
Basically, if your image or your JavaScript, if you need the browser to download, then you need to bust the cache, right? And to bust the cache, you need to change the URL of your JavaScript. So normally how we do it, is like our build pipeline is generating a hash from the content of the JavaScript. So if the content changes, it generates a new hash. That means that for the browser, it's a new asset. So it's going to download it from the server again. Until then, it's just going to be like, hey, I'm always going to use it from the cache. No. So trash junk CSS, the CSS that we were not using, and JavaScript that we were not using on the front end. How did you find that? Nowadays you have these like bundlers, if you're using like Webpack or something that can do these kind of things for you, like tree shaking, maybe roll up or something like that. We're not using any of those fancy stuff on the back. So on the back end, so what we did was we leveraged DevTools. So DevTools has this new coverage panel. Basically, you start recording it, and it tells you all the JavaScript, how many percentage of your JavaScript actually end up not being used. How many percentage of your CSS actually end up not being used. And you can click on those things, and it will actually tell you on the source code itself, like, hey, these CSS are being used, these are not being used. It's really, really cool. So we're using Bootstrap, so there are a lot of junk from Bootstrap that we don't end up using. But we managed to see, like, hey, these are some plugins that we're no longer using. There were some like slider plugin that there are no sliders on our website, so we just removed those plugins using these tools. And this tool is really, really useful for us to see how much of the CSS that we send and JavaScript that we send down the wire are useless, basically. I think it's only in Canary right now, this coverage tool, basically, by the way. So that's the DevTools coverage. And the next thing we did was inline critical CSS and load the rest async. Why we did that, we need to understand the browser behavior again. So basically, browser CSS is render blocking. What does that mean? It's like browser parses the HTML, sees that there is CSS in the head, and then it doesn't show anything until it gets the CSS and builds the CSS, and only then it renders stuff onto the screen. So if your CSS is slow somehow, it will actually wait until the CSS is downloaded before anything appears in the screen. It's the same if you put the CSS in the body tag. The only way I found that you could progressively render stuff is basically having an inline script. Somehow, if you have a script tag, browser is like flushing all the content that it has so far on the screen. Otherwise, it will wait until the CSS is completely downloaded. That's why it's called CSS is render blocking. So what we did was like everything that's required to show the content above the fold for our application, we inline it on our head, on the head of the document. So we use tools from Eddie Osmani. I'll show you guys later. But basically, you inline the things that you need to show immediately on the head of the document, and the rest you load asynchronously. Why do you need to load asynchronously? Because otherwise the browser will wait until the CSS is downloaded. We want things to be shown as soon as possible. So let me show you a demo of that, how that works. So critical CSS. So over here, we got some CSS inline, and the rest is downloaded asynchronously. Both of the CSS file is actually really, really slow. But in this case, the browser waits until the entire CSS is downloaded. So it's like 3 seconds delay. So it waits till 3 seconds until displaying anything. But here, even though the CSS is slow, it flushes the inline CSS right away and displays the rest when the async CSS comes in. So how do you achieve that? There's this tool from Eddie Osmani called Critical. And it automatically generates this inline CSS for you, and also generates the code that will load the rest asynchronously. It's really easy to implement in your build pipeline. I really recommend you use that. About the inline CSS, why do we want it inline in the first place? Because your critical CSS needs to be within the first 14 kilobyte. And to know the reason why, it's a little bit on the network level, on the TCP level. So basically, when a client, your browser makes a request to the server for your HTML page, it's not going to give back everything at once, right? It's so as not to overwhelm the network, TCP always starts slow. What does that mean? It's like it's going to wait. First of all, there's this configuration on the server side and on the browser side for the size of the bytes that can come in from the server. And usually it's 14 kilobyte. So that server is going to be like, send the first 14 kilobyte of your HTML, then it's going to wait until it gets the acknowledgement back from the client. And then it's going to, when it receives the acknowledgement from the client, it's going to send 28 kilobyte, and then 56 kilobyte like that. So it starts slow in steps. And that's just to prevent the network congestion. So what do we achieve? If we put our inline CSS on the first 14 kilobyte, our application is ready to display everything to the user on the first server round trip. Otherwise, it would have to go through many round trips before the content arrives and the browser is able to display. So that was our goal, put everything as soon as possible. So what we did, we inline our critical CSS using the tool, Eddie Osmani's critical tool, and load the rest asynchronously, and also minify the HTML. So if you look into our source code, kind of looks like this. And here is our inline CSS. And this is definitely within the first 14 kilobyte. So when the browser receives this, It has everything that it needs to render nondutch.nl immediately. And the rest over here, down here, we load the CSS asynchronously. So that's about the inlining of the CSS. And the last thing we did, yeah?
Doesn't it load the images if they are in the first 40 kilobytes?
It will load the images if they're in the first 14 kilobyte. Yeah. But browser will always, it will queue the image request, but it will queue it with a low priority. So if there are other resources within the first 14 kilobyte like CSS and JavaScript, it will request those first. So browser has this queuing priority thingy that is actually works well because it's a standard for the priority. Images always go in the end.
So you have a big banner on your website,
Yeah.
and that's not in the first 14 kilobyte. Do you use placeholder in the first?
No, what we use is the thing that I showed earlier, which is this one, the preload.
Oh, right, so it's already there.
Yeah, so if you check our source code, which is where? So it's down here. So link rel preload. As soon as the browser sees it, it's going to download it. If it was, so we have it as a CSS background image, right? This actually comes as a background image. If we had only done that, then browser is actually going to wait until the CSS is downloaded. And even then, it sees the background, but it's going to queue it as a low priority, so probably the JavaScript will happen first. But we know that the image needs to come in really quick because we're displaying it, so we put in the link rel preload, and it comes in really fast.
So it's important to actually put the link with preloading in first 13 kilobytes.
Yeah, yeah. If it's really vital, it's important to put it there as well. Yeah, definitely. It needs to come in fast. So the last thing we did was actually eliminating the network completely, and now it's possible using the awesome service workers, right? So service workers are these like if you guys have heard about the progressive web apps phenomenon that's happening right now. Service worker is one of the giant pillars behind this progressive web app. What does it allow you to do? It allows you to do a lot of stuff, and one of the things is completely remove network from your application. It can completely serve your application from the disk, from the client itself. Other things it can do is like push notification and background syncing and all that cool stuff. We don't have that, but we use it to make our website completely offline. And actually, service worker appears scary, but it's really simple to implement as we experience. So I want to share you guys, give a crash course on service worker, so to say. First thing you need to do is in your HTML that you're serving, you need to register the service worker. If the browser doesn't support, then you just bail out. You do nothing, right? If service worker in Navigator, then you register the service worker. You give a path to your service worker file. Then the browser downloads the service worker. And service worker is just JavaScript. That gets executed in its own scope, separate thread. It's just a JavaScript worker. And then you have a code like this in your service worker file. Self adding listener install. When the browser downloads the service worker for the first time, it's going to fire install event on the service worker so your code gets run, whatever's in here. In the install event, you want to cache what we do. Maybe it's better to show the code, our code. So we got service worker over here. DevTools has an amazing support for service workers, so I can just unregister to force download the service worker again, reload the page. Sources. Oh. Now it's not even there. Let's try it again. Yeah, there it is. So this is our service worker, and we cache a lot of stuff in our service worker. So basically, when the service worker installs for the first time, it goes through this bit of code where what we are doing is we are fetching all these assets that we define in the array. We fetch it and put it into the cache over here. Cache.put, every URL that we fetch, we put into the service worker cache. And that happens during the install. And after install, activate fires. What do you do in activate? After the activate event is handled, the browser is now, the service worker is actually controlling your application. So what do you do in the activate? If you have like a new version of service worker and you want to migrate things, like let's say you change the cache name or something, you do those kind of things in the activate. So once the activate runs, the service worker is controlling. And what does that mean? That means that every request that your application makes, it goes through the service worker from now on. So you can intercept those requests and see like, hey, this request, we already got it from the cache, so we'll just deliver it from the cache. How that looks like is like add event listener fetch over here. Right? You listen to the fetch events, all the HTML, CSS, JavaScript that our application needs, it comes to the same code. We check it against the cache, we match it. If there is a cache hit, then we return the response immediately from the cache. Never hits the network, otherwise we fetch it from the network and put it into the, oh, we don't put it into the cache, but otherwise we fall back to the network request. So in this way, we completely remove the network activity from our application. So if you look into our network and reload this page, there's 0 bytes transferred. And everything is served from the disk, which is a lot faster than the network, of course, and it becomes insanely fast. And if we actually go completely offline and reload the page, again, everything still works. So that's the service worker. And it's, like I said, it's just 4 steps. First, register your service worker. Second, fetch all the URLs that you want to cache and put it into the cache in the install event. Then happens activate. Activate is basically cleaning up the old cache and stuff, and then start intercepting the network request and serve it from the cache. So that's it. Yeah.
This is only really efficient if you know already that somebody is going to queue 5 pages, and you got those 5 pages in the first step. Because otherwise, we already have this with the browser cache, which is loading it and then serving it from cache as well.
Yeah, but you need to be online for that. So as soon as you have everything on the browser cache, right?
But you have to get it in the cache first, so you have to get online to get the page the first time.
Yeah, of course, of course. So that's the same for the native application as well, right? Like native application works with live data as well. So you need to be online for the first time before you see something. But your UI, your application shell, those are the things that actually can be installed, just like you install the native application. It's the same idea for the web. So you basically have a shell in a data-intensive application. You create a shell. You create a shell of the application that contains header, that contains all the other stuff. And once the user gets that, becomes online, you have those in the service worker cache. So even if you're online, the browser is going to get it from the service worker cache. That's different from browser cache because if the browser has stuff already in the cache, but you're offline, the browser is going to show that offline page. You don't get, the browser is not going to look into the cache and say like, hey, I got it, I'll show it even if you're online. That's the difference. So, so let's say you're working on a banking app or something. So what we could do is we can have all our JavaScript, UI, HTML stuff in the service worker cache. So if the user goes there, even the data, because service worker is able to interact with the IndexedDB. So let's say you have those transaction information in IndexedDB, you can show them immediately to the user even when he's offline. Of course, you got to notify that he's offline, so the data may not be the freshest one, but you can show them, and you can even do interactions like transactions and stuff, and later when the user becomes online, synchronize it with the actual database. So this is service worker is like a step towards this native experience that the native application users have been enjoying for a long time, basically. So with all those in place, the end result was we managed to get 100 on Google PSI, which is really, really great. Yeah.
How did you handle the loading of analytics.js? Because they also showed that message that the cache is set to 2 hours. It should be longer.
That's a good question. Let's see. Non-Dutch. Go online. Looks like the analytics is no longer requested anymore.
That's one way to fix it.
That's one way to fix it, indeed. Yeah, because analytics is from Google, and unless Google is sending out all the headers, it wouldn't give us all the marks for the caching, indeed. Yeah, that's correct. But I think we have completely dropped it. GA.js. That looks like it's completely gone. That's one way to fix it. So on Speed Index, it's a tricky situation because it depends on a lot of factors. The mobile device that we are testing against, the network condition and everything. But when testing on a crappy 3G network on a browser, we are getting around 1,000 milliseconds. So sometimes we are on 900, sometimes we are on 1200. So it's not always stable under 1,000 milliseconds, but that's a long way from where we came from, which was 3,000 something milliseconds where we started and 45 on Google PageSpeed Insights. And on Lighthouse, at least the version that I ran it against the last time, we got 100 on Lighthouse as well. So using all these different techniques, and it was a nice, fun experiment basically for a day to apply all these crazy techniques, apply all these newer APIs. As long as you can feature detect those APIs, you can apply them and progressively enhance your application and make them super fast. And that's what I wanted to share with you guys today. Thanks. Thank you very much. Are there more questions?
What does the site cost?
I'm sorry?
Oh,
let's check it out.
It's some chat over
You already did
Oh, yeah.
With
yeah.
MLS.nl, right?
It's 41 cents in Canada. Canada seems to be the most expensive. It's always Canada on the top of the list.
Developers.nl cost.
Let's check it out. It's gonna take a while. Meanwhile, any questions while this is running?
Have you tried WebAssembly?
No. WebAssembly, yeah. First of all, I'm not a C++ or developer, and I don't see WebAssembly being advantageous for us in this situation. I see, for example, if you're developing a game, or let's say if you're creating like a virtual DOM diffing algorithm, there I can see an advantage. With normal website, WebAssembly I think is an overkill. Like why would I? And one of the best thing about the web, the JavaScript, CSS, HTML, is that it's all open. Everyone can inspect the source and tinker with it, right? And with WebAssembly, all of a sudden those things are gone. So
Some people see it as an advantage because you hide your.
yeah, definitely. I think it will be a big so when WebAssembly becomes mainstream. I think it will be like a big jump in the same way when we had Ajax calls. You know, like that basically changed the game, right? So I think WebAssembly will do something similar, but it will be a long time before all the developers get into the board for the reasons that's my opinion. That's not a fact. Yeah.
Yeah, in terms of the progressive JPEG, is it, do you need to alter your files, or is it just another way to handle them in the browser? Do you,
No, you need to encode your JPEGs as progressive JPEGs, and most of the image optimizers basically handle the progressive as an option.
Okay.
So we were using some image optim, and it had a CLI option as well to encode JPEGs as progressive.
And this one was supported in major browsers?
This one has been going on for a long time.
Okay.
It's supported in pretty much all the browsers, but there is a catch though. In some browsers, the progressive JPEGs are supported as in they render it, but they render it only after everything is downloaded, which is not really progressive. They support it, but they don't progressively render.
Okay. So it's not progressive, but it's also not slower than just line rendering, right?
slowly because files are bigger.
The file you showed is smaller.
Oh,
It's a little smaller. The progressive JPEG is just a little
there's
smaller.
something going on with loss of pressure. It can be infinitely smaller.
Progressive JPEG?
No. With the same information,
With the same information, I think it would be.
It would be similar. I would actually progressive JPEGs from what I've seen from our images. It was consistently smaller than the progressive the baseline counterparts.
You can try like take one source image like in some PMP or something, and the same encoder try to do it with progressive or non-progressive. Also, we'll see the difference.
Oh, you want to do it now? Sure. By the way, $19.
Maybe just set on the cable running to the TV.
Yeah.
No, it's not. It's fixed.
I think it's gonna come. Yeah, $19 for developers. A lot less. Oh, 19 cents. Yeah.
Did you consider using HTTP2 on your performance uptime?
It's in our to-do, but it was just way too big to do it in a day.
Doing the multiple requests.
Yeah, definitely. That's definitely the next big step towards performance. Yeah.
And one other thing on the progressive JPEG, what we've seen when we want to support retina resolution, and what you can do is with JPEGs, you double or actually quadruple the bytes, that you can really lower the quality to less than 50%. It will still show up very nice.
Yeah. I've read about that technique, but there is a trade-off for that one though. I'm curious what you think about it. Because the browser needs to scale the size, right? Scale the size tremendously, so there's a lot of CPU work being done on the front end to scale the image.
You should use responsive images and just tell the browser to load the exact size of the image. Depending on the device, it's a laptop or your mobile phone. Just load a small image.
Yeah, but that is actually a good technique as well, because you can drop the quality level really high.
It can be used together.
Yes,
true.
You should not scale it.
No.
If you detect CMS support, you can serve the JPEG but with much lower quality. Because otherwise your JPEG, if you serve the high quality one, then it will be very large.
Yeah. Progressive JPEG. So let's just grab a JPEG from Developers.nl. This seems like a huge one.
It is.
Oh, actually, you know. Oh, it's a PNG.
There was a one.
Oh, there's no here. JPG.
It's not that you double.
It's not really that big.
It's not that you double compress the image when you run it as progressive image. So if you change it to progressive.
Okay. This is Rotterdam. Go to Google image. Grab
You're going to
this.
use JPEG as source image. It's always going to be smaller. It's another time.
Sorry?
You should use a PNG file as source. Yeah, Otherwise, you're going to encode it twice.
Yes.
No, we can also convert the baseline JPEG to a progressive JPEG. Yeah. Shall we try that out?
Well, let's do it later, but you should take something like lossless pictures, WebP or something, and convert it to JPEG. The same image, quality settings, but one progressive, one non-progressive, and then see if there is a difference, and who wins. And one small thing that you can do, I'm not sure if it's a big win, there is a DNS professional.
Shall we do this after the meetup? Then we can share the findings in the comments of the meetup page or something like that. So it's gonna take a bit, maybe now.
Okay.
Questions? Other questions? Or we could do it now then. If we're done anyway.
In that case, thanks for the talk this time.
Thank you very much.
Next time, we've got a little present for you.
Thank you. Appreciate it.
Presentation. Next time we'll be talking about GraphQL. It will be in approximately a month. I have not really in mind when it is. It's up on the monitor over there.
And on the screen.
And over here. Even better. June 28th, apparently. So please feel welcome to attend that. We've got a little, as every time, we've got a little survey for you to fill out, which gives us a bit of feedback on how we're organizing this, so we can, well, at least try to improve on it. So if you please answer that, we would be very thankful, grateful. Yes. And we've got well, more beer and more some chips and more technologies for you to enjoy and discuss after this.
Okay.
Thanks.
Cool. Thanks.
Let's go grab beer.